Why does the moon change color? On the night of July 17th in New Jersey, I breathed the toxic air of the Canadian wildfire smoke and noticed the glow of a moon far in the distance. It was a waxing crescent moon, but it felt oddly different from other moons. It had a brilliant orange hue that was totally unique compared to past moons. The color was just more dramatic, so I did some research, and two natural events popped up on the radar. Number one was Rayleigh Scattering, and number two was the Canadian wildfires. It was a combination of a natural event that happens every day with the unfortunate wildfires that caused this moon's color transition from a bright orange to a crimson red crescent moon. Let me clarify what a waxing crescent moon actually is. It happens right after a new moon occurs at 0% illumination. That sliver of a moon that grows after a new moon is called a waxing crescent, and it keeps growing until it reaches the first quarter moon, which visually looks like a half moon. So back to the standard color of a waxing crescent. If you watch this moon phase when it is high in the night sky, it will look white, or an off-white. But as it gets lowered towards the horizon, the white transitions into a yellow or dull golden color. This color change can be explained by Rayleigh scattering. What is Rayleigh scattering? Rayleigh scattering was mathematically explained by an English physicist named Lord Rayleigh. He determined the blue light scatters 10 times more than red light. The reason is that blue light has a shorter wavelength, while red light has a much longer wavelength. As blue light encounters more air molecules closer to the Earth's surface, it gets bounced around more due to the shorter wavelength. The higher you look in the sky, the fewer air molecules there are, so the blue light wavelength doesn't get scattered as much. How often does Rayleigh scattering happen? Rayleigh scattering happens every single day and night. In regards to the moon, it happens whether it's a crescent moon, a quarter moon, a full moon, or even a new moon. The moon will always look more white the farther away it is from the horizon, and look more yellow the closer it gets to the horizon. So how did the combination of Rayleigh scattering and the Canadian wildfires affect the moon's color? The Canadian wildfire smoke altered the color dramatically. At approximately 9:20 p.m. on July 17th in New Jersey, the 11% waxing crescent moon showed out as a vibrant orange colored crescent moon. When I walked outside, the color was intense against the dark sky. I had to grab my telephoto lens and zoom in on this impressive event. A moon event that changed from orange to a crimson red in a matter of just 20 minutes. By 9:45, the moon was turning that darker red and starting to fade into the horizon. What are the effects of Rayleigh scattering on every moon as it transitions to a different moon phase? All moon phases go from a white moon high in the night sky to a yellow or orange moon as it inches closer to the horizon. A moon's color is really a dark gray, but the sun illuminates the moon with its powerful white light. If we see a moon that looks white, that means the air is thinner and farther from our horizon. As it gets later in the night, the moon transitions to a yellow or orange or a pale gold color as it reaches the horizon. Remember, it is not the moon or the sun that is changing color. The color changes due to the thickness of the air as the moon rotates downward. This is where Rayleigh scattering helps us understand more about the wavelengths of color. Rayleigh scattering showed that the blue light wavelength is shorter than almost every other color, with red light having the longest wavelength. Because blue light has a shorter wavelength, the sky looks blue during the day when there are fewer particles up in the atmosphere. Blue light thrives in the thinner air up in the sky, but once you reach the ground, the air is much thicker and gas particles are packed tighter together. What other environmental obstacles create color changes in the moon? As the moon gets closer to your visual horizon, thicker air is not the only physical barrier that affects the color of the moon. We generally think that blue light and other colors are blocked by air, which is composed of nitrogen and oxygen molecules. While this is true, there are other obstacles that can alter the color of the moon. As we recap, The Canadian wildfire smoke is a form of air pollution that was directly responsible for the crimson-red waxing crescent moon on July 17th, around 9:25 p.m. Actually, I think it was 9:45 p.m., sorry. Without the smoke, the moon would not have been that deep red. In addition to smoke, there's also water vapor, urban smog, dust storms, and volcanic ash that can alter the color of the moon. As a final reminder, the moon is only visible because of the light that comes from the sun. The sun makes the moon look white. It is all the elements of Earth's atmosphere that gives the moon the colors like yellow, orange, or red. Lord Rayleigh and his theory on Rayleigh scattering provide us with insight into how air gases affect the colors we see in the moon, while paving the way to understand how pollution and other elements alter it.